Good morning, sixth grade. This video is for Tuesday, April 28th. Remember, there's no Zoom today, but I'm going to go over the second part of that PowerPoint and what you're expected to do for today. So, your schedule from Edmodo. You are going to watch this instructional video. You're going to watch the video on Pearson, You Engineer It, Windmills of the Future, and you're going to complete the interactive activity on Pearson, which is Winds Across the Globe, which here's the video, and here is the interactive activity. And I'm going to just preview the interactive activity for you guys really quick so you see it. This one is only 4 slides as well. If you see right here, 4, make sure you read all the information on the slides. Make sure you follow the instructions on here, drag and drop the arrows. So you have to move these arrows around and put them where they belong based, I'm just putting them in any place. So based on where they're supposed to go for this picture. But this is a picture of the, I think if you guys actually Google Coriolis, the Coriolis effect, wow, I'm not able to say it. I'm pretty sure that's what this goes with. So the Coriolis effect. So Google it and you guys should be able to find the answer for how this looks. And then you have these 2 questions to answer and this one as well. Actually, this looks like this is the answer. So make sure you guys answer the slide 2 correctly. Okay, I'm going to go back to share my PowerPoint. Okay, so this is where I left off yesterday. This is where I'm starting today. So global winds. Global winds form from temperature difference between the equator and the poles. These differences produce giant convection currents in the atmosphere. Warm air rises at the equator and cold air sinks at the poles. Therefore, air pressure tends to be lower near the equator and greater near the poles. The difference in pressure causes the winds at Earth's surface to blow from the poles towards the equator. Higher in the atmosphere, air blows from the equator towards the poles. Those air movements produce global winds. This is what I was talking about with Googling Coriolis effect. So Earth's rotation. If Earth did not rotate on its axis, global winds would blow in straight lines. Global winds get deflected or shifted by Earth's rotation. As the winds blow, Earth rotates from west to east underneath them, making it seem as if the winds curve. The way Earth's rotation makes the winds curve is called the Coriolis effect. Again, Google Coriolis effect or look at that last slide so you don't get slide 2 wrong on your assignments. Because of the Coriolis effect, global winds in the northern hemisphere gradually turn toward the right. A wind blowing toward the south gradually turns towards the southwest. In the southern hemisphere, winds curve towards the left. So here's the southern hemisphere, so the winds would go toward the left. And then if you're looking at this, easterlies, east is to the left, so north, south, east, west. No, north, south. No, I did that wrong. Wow. North, south, east, west. Okay, the global wind belt. The Coriolis effect, global convection currents, and other factors combine to produce a pattern of calm areas and global wind belts around Earth. Global winds affect local weather by moving masses of air from one place to another. The air masses affect the temperature, rainfall, and air pressure. Overall, the global wind belts move energy away from the equator and towards the poles. This helps to equalize the temperature, allowing life to survive in a larger range of latitudes on Earth. And the jet stream. About 10 kilometers above Earth's surface are bands of high-speed winds called jet streams. They generally blow from west to east of speeds of at speeds of 200 to 400 kilometers per hour. As the jet streams travel around Earth, they wander north and south along wavy patterns that vary over time. The jet streams greatly affect local weather. Weather forecasters track the jet streams to predict temperature and precipitation. Remember, precipitation is rainfall or snow. If the polar jet stream wanders further south than usual in the winter, it could mean colder temperatures and snowy conditions in areas north of the jet stream. If the jet stream wanders further north than usual, then warmer air moves up from the south, and warmer temperatures are predicted for areas south of the jet stream. And that is it for that presentation. Tomorrow, you guys will have to do your virtual lab. And remember to make sure you watch your video, the instructional video, because I'm going to go step by step on what you need to do to complete your virtual lab. You have Wednesday and Thursday to complete your virtual lab. And remember, no Zoom today. I will see you guys tomorrow. Bye.